we are going to pick up on 2-6, which is talking about these complex numbers, which I've kind of been referring to throughout the year. We talked about how they're going to be imaginary numbers. So the first one we're going to be on page 172, looks like. And we're going to continue working through these imaginaries, how you can combine like terms, what they look like. So the first thing, if we were going to do this, and I'm going to do a couple of them, and then I'm going to ask you to do some, maybe for homework out of the skills that I put up on Portal. Remember, that's that PDF file. So we're going to do some together in class real quick. This will be with the substitutes, so if you have questions, I'll be in the next day. We can go through it together. So first thing about A that's really tricky is you've got to distribute that negative sign. So the first thing I need to do, like I said, is I've got to distribute this negative sign. So before I can drop these parentheses so I can combine like terms, because this 3 and this 1 are like terms, before I can go ahead and combine them, I need to distribute that negative. So it's going to become 3 plus 2i, and then this becomes a -1 and a positive 6i. And then I can actually combine this 3 with this -1, and I combine this with this. And when I do that, 3 minus 1 is 2, and 2i plus 6 more i's would be a total of 8i. So that would be that simplified. Again, it would look like this: 3 minus 1 plus 2i plus 6i. I just move these guys so they're right next to each other. Remember, when I move it, I keep my sign that is with it, so that's why I -1. All right, what can be combined here? We have 4i, we have an I, we have 3, we have -6, and -1. So I can move all those together. So I'm going to put the 3 here, -6, so that's gone. I've used that. -1, I've used that. Now I just have plus 4i. How do I know it's a plus? Because in front of it there's nothing, so that means it's a plus I. And 3 minus 6 is a -3. So I get -3 minus 1. 4i plus 1i is going to be a plus 5i. Remember, that's an imaginary one that's not there. And then -3 minus 1 is a -4 plus 5i. And normally when we're writing this, we always want to put the real number first, and we put the imaginary number second, like we did in both these examples. Alright, again, what do you think I'm going to do with this? I'm going to distribute that just like we would if it was a normal number, except 5 times 3 is 15, and keep the I.
Mr. Scales, please come.
And then after I distribute that, I distribute again with this, and negative times that is going to be a -10i squared. But we have talked about any time that you get an I squared, that really is equal to a -1. So I can really write this as 15i minus 10 times a -1. And negative and negative make it a positive, so I end up with 10, where we put the real number first, plus 15i. And again, why did that become positive? Because a negative times a negative became a positive 10, and this was a positive 15i because there's nothing written in front of it. Alright, so for D, I'm going to let you try that for homework. Remember, all you're going to do, so circle that, that's going to be homework. What you have to do is you're going to distribute this, distribute this, distribute this, distribute this, combine like terms. If you get I squared, remember those turn into -1s, which are going to combine with whole numbers. So at the end, you should actually have just two things: a real number and plus or minus an imaginary. So you should have a real number plus an imaginary number. That's just to give you a hint. You should only end up with two things when you figure this problem out. Alright, these guys right here, they're trying to show you something. Since we reviewed this in the beginning of the year, if we did this was x plus 2 and x minus 2. I hope you remember, I called these difference of squares. And the reason they were so important is because what happened to my middle term every time is that it canceled out. So if I distributed this out, it would be x squared. This times this is a -2x. This times this is a positive 2x. This times this is a -4. And what happens to these guys every time we have difference of squares? They cancel out, so I'm left with x squared minus 4. So essentially, whenever I have a difference of squares, like if I had x squared minus 3 and x squared plus 3, what I can realize is all I have to do is square this and square this. So x squared, 9. So that was that squared right here. This was this squared right here, and then subtract them. And that's what my end result is going to be every time. The reason we're talking about that is, remember, the middle term cancels out. So the middle term would have canceled out in this one down here. Well, do you see right here? We've got a difference of squares problems, and I know it has imaginary numbers, but that's no big deal. We can distribute the first one out the long way, but then we're going to do it faster for the next couple. And you'll do C, and you will do D for homework. So I'm going to do A and B with you. We're going to do A the long way, we're going to do B the short way, and then you choose C and D. I don't care if you do long way or short way. 2 times 2 is 4. 2 times that is going to be a negative 2i. I times 2 is going to be a positive 2i. And I times I is going to be a negative I. Well, what happens right here to this is it cancels out. And I end up with, oh, that's I squared, sorry about that. This is really a negative 1. And what happens when I have a minus and a negative 1? It becomes 4 plus 1, which equals 5. So my end result was just 5. If I did it the short way, what would this be squared? 4. If I did this squared, what would it be? I squared, and subtracting them. Well, again, what is I squared? It's really a negative 1. 4 plus 1 equals 5. Same end result, just did it a much faster way. Alright, let's try the fast way on this. This you got to be careful of because it's a fraction. 1/2 squared just means 1/2 times 1/2. Well, 1/2 times 1/2, top times top, bottom times bottom, 1/4. So I end up with 1/4 in the front minus I times I is just I squared. And the reason I can do this is because I know my middle term every time when I have the same thing, but one is plus and one is minus. We call those difference of squares. I know my middle is going to cancel out, so I end up with 1/4. This turns into a negative 1, which is really plus 1. And I end up with, you can write this as 5/4 if you want to, or you can write it as 1 1/4. I don't really care. So tonight for homework, you're going to try C and D, doing the same thing that we did up there. So these things that you just actually did right here have a name. Their name is complex conjugates. Complex conjugates. If you noticed, you had one form where you had some number plus di. Its conjugate pair would be the same exact number here, the same exact number here, but instead of a plus, you have a minus. And then, like I said, all you have to do is square the first number and square the second one. And the reason that it's going to be a plus in the middle here is because I times I is going to be I squared, which turns into a negative 1. But don't worry about that. Just follow the steps that I've kind of gone through with you. All right. So before we get into conjugate pairs, we're going to start talking about, well, these guys right here. How many terms are there? Remember, what separates terms we've talked about are plus or minus signs. So right here, there's only 2, so this would be a binomial. We're not going to do B. B's kind of nasty because there's this thing with distributing or factoring. We're not going to talk about it. Right here, these guys are not like terms. So again, they're saying right here, this is a monomial. And again, it's kind of the weird part of the book. The reason they're saying that is, you see how they have the x squared in common? You can write that as 3 halves minus 1/4 I x squared. So they're saying, because this is x squared, there's only one number in front of it. I know that looks like 2, but it's together as part of the x squared. So they're saying that's why it's a monomial. These are like terms. But I don't like that problem again. This one's not too bad. 1, 2, we cannot combine those things, so this would be a trinomial. Not too worried about that for as far as tests. Alright, this we will need. This we will need. We'll need to know what we can combine, what we cannot combine, why we can combine them, and so forth. So this is going to be a very important page that we're going to go through. Again, I'll probably have you do some of these questions tonight for homework. If you look at this right here, these are like terms because they have an x and an I. So how many xi's do I have? I really have 2 xi. Now the thing you have to be careful of is this looks a lot like xi times xi, but it's not. Xi times xi would actually be x squared I squared, which we know I squared would turn into a -1, which would then make this a negative x, opposite of x squared. So please see the difference between these two. They're not the same. When you add them, you get 2 xi's, because just like you're counting. How many do I have here? I have 1. How many do I have here? I have 1. How many do I have if I put them together? I have 2 of them. Now B looks fairly similar, but here we have xi, here we have xy. You cannot combine those. That is as simple as it gets, so that is already simplified. You cannot simplify that any further, no more work to do. Don't get freaked out by these problems down here. Take your time on them. I'm going to have you do E for homework. Notice I'm circling all the ones that you should do for homework. If you can't remember which ones you do, you can look them up on YouTube. So here we go. Let's start with C. Does this, and I'm gonna color code this, so this hopefully will make this easier. Can we combine this with anything? We can combine this with this. We can combine I's with I's. So actually I told you I was going to color code that, so let me retry that. Here we go. If I was going to color code that like I told you I was, we have X's that can combine with X's. We have I's that can combine with I's. There is nothing that is like this guy. He's a loner. And this guy right here has nothing that he can combine with. I'm going to erase that blue because it's a little hard for me to read with this, but those guys are all alone. We could throw Dylan out there again. So anyways, here we go. If I have a negative 2.5x and I add, so I got negative 2.5x and I can add 4x. Those are like terms. Then I said I can combine plus 3i and plus 1.8i. And then at the end, I said I had minus xi, doesn't have anything in common, blue, it's thick, and then plus 9. So those are the like terms. So go ahead and combine those. When you combine those, and you take 2.5 and you minus or you add up 4, you should end up with 1.5x. That's that combined. When you add these guys, you should end up with a plus 4.8i, and then this guy doesn't combine with anything, so it's minus xi plus 9. So I tried to show you which ones could be combined together. Alright, I'm going to do D with you, and then you'll do E on your own tonight. Just give you a preview. You would just distribute like we've needed to have practice on. So x plus 3i, what does it mean when you square something? It really means that you multiply by itself. So I'm going to write this down twice, and again I'm going to distribute. We need practice on this distributing. So x times x, I'm going to write that in red, will be x squared. So that was this times this. Try to maybe do this in green. This times this will get me to a plus 3i. This times this will get me to another plus 3i. And finally, this times this gets me, be careful on this, 3 times 3 is, and it's a positive, because positive times positive is positive, 9. I times I is I squared. But you have to be careful on this one, because these guys right here are like terms. And so I get, when I finish this up, it becomes x squared. That's from right here. This plus this, if I have 3 i's and I add 3 more, I get 6 i's. But when I have an I squared, we've told you can replace that with a -1. -1 times a positive 9 is a -9. That would be your complete final answer. So we're on the next page, and we're supposed to analyze these two methods. Both of these people, both these girls got the answer correct. They are both correct. If you look, they both get 5 plus 10i. But they each did it a little bit different. And if you look, the top girl, this girl, her method is much smarter. That's how we've talked about working smarter and not harder. She looks at these numbers right here, and she realizes right here, hopefully you realize that is called a conjugate pair. She's got a 2 and a 2. She's got an I. She's got an I. One is negative and one is plus. That means it's a conjugate pair. And we told you how to multiply those really quick. As soon as I realized that I have 2i, or 2 minus I, and 2 plus I told you you can just square the first number, which is 4, minus, because they're both 3 different signs, I squared. Because you know what's going to happen to the middle terms when you know it's difference of squares. The middle terms are going to cancel out. So then I can turn this into a -1, and 4 minus a -1 really turns to a plus, and this becomes a 5. I know there's a lot going on. That's why that middle school math is so important. If we follow, that's what she did. She said, you know what? I'm going to use commutative property, which we've talked about. She said, you know what? I'm going to move this one here, and I'm going to move this one back. She did that right here. She moved this one forward, that bubble forward, and pushed this bubble to the back. She then did that conjugate pair that we just talked about, and that's how she got this 5 right here. She then distributes the 5. 5 times 1 is 5. 5 times 2i is 10i. You can follow this girl, and she just did it the normal way. She just did it the way the problem gave it to her. And she just did this times this, this times this, this times this, and this times this. That's why she ends up with 2 plus 3i minus 2i squared. She takes out the I squared and puts in a -1. She combines her like terms because this turns into a +2, and 2 plus 2 is 4. That's where she gets the 4, and the 3i is from right there. This bubble, notice, she just keeps carrying it with her. She then distributes this, and you can follow her with this, and she does everything correct. Like I said, she gets the same answer, but there is definitely something that is a quicker way, which is what the other girl did. So either way would work. There's definitely a smarter way. We can look through these guys. Again, there's going to be a smarter way to do this, and there's going to be a tougher way to do this. This guy right here just does the problem the way it's given to him. This guy right here, all he does is, and I shouldn't star that because I don't like that way better. That's not the person who actually thought through the problem. Sorry about that. The person who thought through the problem is actually Aiden down here. He just comes through and he just distributes this times this, this times this, this times this, gets this down here. He takes this, distributes this times this, this times this, this times this, this times this, and gets this down here. You can go through the problem and make sure you get that. Then if you notice, because it's all, he's already done all of his distributing, right down here he says, okay, I can drop these parentheses because it's all plus and minus, and he says, what are like terms? The x squareds are like terms, which is why they are right there. Then he said, oh, wait, this x is also like term with this x, and this xi is like term with this xi, and this 3i is like terms with this 9i. So he just put all those in the bubbles together. That's where he moved them. There's the black ones that we put. Here's the green ones that we put. Here's the blue ones that we put. And then he just combined like terms and got this answer. You have 2x squareds, 2x squareds. You have 6x's, 6x's. You have 3 of these and 1 more is going to be 4 of them. And you have 3 i's plus 9 more is going to be 12 i's. Now, if you look at this guy, he did something a little different. Aiden said, you know what? If I look at these two numbers, this right here as one number, and this as a second number. He said, you know what they have? They have an x plus 3 together. So I'm going to factor out that x plus 3. I'm going to say, you know what? Take that x plus 3 out. And I multiply that by what's left over. Well, what's left over is, in this bubble, x plus I plus x plus 3. So what he did is he took that x plus 3, that common factor that they have, and he pulled it out. He then simplified all this stuff and said, hey, I can add these together and that gets me 2 x's. I can add these together and that gets me 4 i's. Then he FOILed this. And a lot of you need practice from that quiz that I just graded. A lot of you need practice on that. And when he finally finishes, there's no like term, so he's able to just circle that, and that's his answer. So go ahead, and I'm going to pick a couple of, actually you're going to do those for homework right there. You're going to do number 7 for homework. If you need help on those, you have examples right up here for doing them. This one is example for B. This is B example. And these up here would be what you need to look for A example. So, example for A is right there. Example for B is right there. And you are supposed to do those 2 for homework. And we are coming to our last problem, problem 4. It says rewrite the quotient with complex. So first, let's find the conjugate. The conjugate of this is going to be the same exact thing, just minus it. So in here, my conjugate would be 7 minus I. And again, if I calculate the product, I know that when I have difference of squares, which is what I'd have, so this is part 1, write the conjugate, that's right here. To then calculate the product means that I'd be going 7 plus I times 7 minus I. Well, this guy right here is telling you, hey, remember, that means you just square A, square B. And so if I square it, I get 49. And then this is going to be a minus, but it's I squared. What happens when you have I squared? It really becomes a negative 1. And a negative minus a negative becomes a positive. So I end up with 49 plus 1, which equals 50. All right, this next one's a little trickier because kids want to change the signs of both of them. Notice over here, this was a 7, this remained a 7. The only thing that changed sign was the back number. So notice, this is still, the conjugate pair for this one is going to still be a negative 5. So I didn't change this one, but this one's going to change to a plus 3i. And if I follow my pattern here, all I have to do is square this one, which gets me to a 25. Minus square this one, which would be 9i squared. Again, my I squareds are turning into a negative 1, so that turns to 25 plus 9, which is 36. So for homework, I want you to try C and D. If you need examples, A and B would be those good examples for that. And here we go, last type of problem. This is where it gets where we're actually going to use that conjugate pair. The whole reason we've been doing this is for this type of problem. Right here, you can rewrite the division of complex numbers by multiplying the divisor and the dividend by the conjugate of the divisor. A lot of hogwash there. Here's what happens. Do you remember when you had 1/2 and you wanted to change it to have a denominator of 4? What did you have to do to make that happen? You times the bottom by 2, but if you remember from middle school, you had to times the top by 2. And why is that? What is really the number 2 over 2 is the number 1. And whenever you times a number by 1, you get that same number out. So again, we're trying to show you, you're just changing the way something looks, but you're not changing the value of it, because when you multiply 1 times 2, you get 2 over 4. 1/2 is equivalent to 2/4. They just look different. I'm going to do that same thing over here, because whatever I multiply this bottom by, I'm going to have to multiply the top by. And so here we go. Here's a trick that helps you out. So if I want to get rid of this denominator, I do not want to have this on the bottom. There's a way that I can get rid of it. I'm not allowed to have an imaginary down in the denominator. That's what we're going to get rid of. So what happens is they rewrite this. This is the original problem. And notice they timesing it by 4 minus 3i, because this is called its conjugate pair. That's the conjugate. And what's going to happen in my conjugate pair is I'm going to get rid of my middle term. So I will no longer have an I in the denominator. That's the trick for doing this. You multiply by the conjugate. So, but remember, whatever I multiply the bottom by, I have to multiply the top by. So that's why you see it written as 4 minus 3i over 4 minus 3i, because this number really is the number 1. So we're not going to change the value of this here. We're just going to change the way it looks. So when they do that, remember, I don't like them writing it like this. I would write it as 4 squared minus 3i, or sorry, that would be 9i squared is the way I would write that. I hope that helps you out. Then all they did here is you have to remember the top is in a parenthesis and both are in the parentheses. So how did they get this top? They multiplied 3 times 4, which is the 12. They multiplied the 3 times the negative 3i and got the 9i. Then so they're distributing the top. So you have to remember to do that. I will do a problem out a little bit more slowly. Not much, but negative 2i times 4 is a negative 8i. Negative 2 times a negative is a positive, and 2 times 3 is 6, and I times I is I squared. So that's where they're getting all those numbers. Now, the next step from here to here is they're just combining like terms. They said, hey, you know what? An I squared is really a negative 1, so that's how that turned into a negative 6 right there. They said, hey, these guys can combine, and if you have negative 9i's and you minus 8 more, you get negative 17. Notice the 12 stayed there. 4 squared is really 16, and I squared is another negative 1, and if I minus a negative 9, it really turns to a positive 9. So that's where all those values came from. They then said, hey, 12 minus 6, those can combine, and that gets me 6 here. Notice that 17 stayed the same, 17i, and 6 plus 9 is 25. So then after that, they're saying, this would be a fine answer for me. That's where I want you to leave it. But hopefully you realize either of these two answers are technically correct. You probably need to know both of them for that EOC thing. Notice if I was adding fractions, if I have 1/2, no, let's not do that. Let's do, if I have 1/4 and I add 2/4. Really what I'm getting is 1 plus 2 on the top over 4. So if I can have a number plus a number and then put it over the same denominator, because I had same denominators over here, if I can go this way, I can go backwards and split them apart. So hopefully you see right here you have 6 minus 17i over 25. How can I split these guys up? I can put 6 over the 25 and then subtract and then put the 17i over 25. That gets them those common denominators. So all they're doing is they're doing this backwards. I know this is a lot. I'm going to go over this tomorrow when I get back. So here we go. I'm going to do these two real quick for you, and then you, for homework, are going to do C and D. So here we go. If I was going to do this problem, it would be 2 minus I over 3 plus 2I. I realize that I do not want this I in the denominator, so I'm going to multiply by its conjugate pair. We just talked about how to find its conjugate pair. Leave the 3 there, change the sign to a minus, and 2i. It's the same exact thing that's over here, just being a subtraction sign in the middle, and whatever I multiply the bottom by, I have to multiply the top by. Now on my bottom, I'm going to end up with this first number squared, so it's going to be 9 minus 2 times 2 is 4i squared over, and this is the part we have a hard time with. Put your parentheses in here. No one's going to tell you to do that. You've got to do that. Distribute that stuff out. 2 times 3 is 6. 2 times negative 2i is negative 4i. Negative I times 3 is a negative 3i. And negative I times the negative is a positive 2i squared. So we have to simplify that further. These guys can combine like terms. This can turn into a negative 1. This can turn into a negative 1. So let's see what that gives us. 6. These combine to a minus 7i. And this right here turns into a minus 2. Over 9 minus, this becomes a negative 1, so this really becomes a plus 4. 6 minus 2 is going to be 4, minus 7i, all over 9 plus 4 is 13. And the other way you can write that, where you need to know both ways, is 4 over 13 minus 7i over 13. Alright, actually I'm just going to let you guys finish that. Try B, C, and D for homework. Again, if you need help, look at what I did for A. This is going to be very similar to this. I'll help you out, get you started with B and C, and hopefully you can finish it off. The conjugate pair for B, you're going to multiply this, hopefully you see this, by 2 plus 3i, and then I'd also multiply the top by 2 plus 3i. And then on C, my conjugate pair would be 1 minus I, and I'd multiply the top by 1 minus I. Alright, see you tomorrow.